Working in response to a brief from SGN, James Fisher NDT are developing an innovative solution to the corrosion mapping inspection of buried Orpheus gas regulators.
Well, we first got involved with SGN to develop a prototype scanner that was capable of scanning the Orpheus regulators. Then the project we're involved with them now is to develop that from a prototype into a fully deployable system.
Orpheus regulators are natural gas pressure reduction modules. Installed below ground, the modules are designed to reduce higher network pressures to lower pressures suitable for SGN's localized distribution networks.
SGN and other network providers have a responsibility to ensure that that equipment is still safe. The current process is they have to excavate the Orpheus regulator and then they do external corrosion thickness tests. So the thought process between ourselves and SGN and subsequently Phoenix was to be able to inspect Orpheus regulators without the need for excavation. We sought some expertise from a company called Phoenix, who we worked with previously, and they came at it from a slightly different approach because of their experience of making ultrasonic scanning equipment.
The gas network around the country has a large number of these Orpheus regulators. Traditionally they're inspected by excavating the entire regulator and looking externally. The aim of this project is to develop a scanner that you just lift the lid and you go inside and you're measuring from the inside the thickness of the regulator.
To deploy the scanner, a spacer is first attached to the top face of the Orpheus valve to provide mounting points for the scanner itself, which is then assembled from three main components. A calibrated rotating ring is attached to the spacer. A rigid supporting frame is then fitted to provide stability for the main scanner mast, which carries the ultrasonic transducers.
So the scope of the project was to inspect 95% of the regulator valve from the inside surface.
A major design challenge was to develop a technique to successfully scan the domed bottom section found in some Orpheus regulators, while avoiding the various internal obstructions.
The issue we have with the bottom dome is because of the central flange causing obstruction, a special scanner has had to be devised in order to scan this dome 100%.
To achieve this, the scanner probe is attached to a length of sprung steel, which ensures the transducer stays in contact with the surface. This cutaway test piece at the Phoenix facility demonstrates how the flexible steel arm moves around the domed regulator base. In a real scanning environment where access is limited, video cameras provide a live image to the operators.
We've got two video cameras on the display so we can see where the ultrasonic probe is, and then also if we detect any corrosion or pitting in the regulator, we can also see it on the video as well.
A unique water couplant, delivery and retrieval system was designed for the Orpheus scanner.
One of the main requirements for the inspection was to be able to pump water to the ultrasonic transducer, which enables it to actually gather the data. And so we developed a couplant recirculation system. Water is pumped to the transducer, it floods to the bottom and then is captured again, sucked back up to the top.
The couplant delivery and retrieval system has been created specifically for this scanner. So you're not left with pools of water at the bottom, it sends down water to the probe and it's all recovered.
A software system is also being developed to map the collected corrosion mapping data onto a 3D model of the regulator.
The inspection is designed to utilise standard ultrasonic instrumentation. However, the actual 3D shape geometry of the Orpheus valve doesn't lend itself very well to being represented on the data sets that we get. There's a program to develop a 3D visualisation where we map the corrosion data back onto the CAD data of the Orpheus valves, which enables us to then pinpoint exactly where on the valves any areas of corrosion are.
Throughout the development, it was important to ensure the scanner system be flexible and easily transportable.
Our design brief has always been with adaptability in mind. We need to be able to adapt quickly to the situation on site.
The main key point was modularity, being able to utilise a number of different smaller modules to build them together into a larger package. So the scanning system breaks down and can be put into a number of rugged transport cases. Without going there, purging the valve and opening the lid, you don't really know what you've got until you turn up on site. So ideally you need to turn up with a big kit of parts that will be able to cover whatever you encounter.
The introduction of this internal corrosion mapping scanner has the potential to deliver considerable financial and time savings compared to traditional scanning methods.
We fulfilled the brief of being able to scan 95% of the internal surface. We took existing technology that we, ourselves and Phoenix, use in different industries, and we adapted it with some very innovative techniques and have the scanner that we see today.
James Fisher NDT offers the latest in innovative NDT technology. More films on ultrasonic inspection techniques can be found on our website and YouTube channel.